Let's look at how we can use Bloom Cloud Engine together with DotProduct handheld scanner. So here's a DotProduct binary file, 31 gigabytes, and we just drag and drop that in the Bloom. The file format from DotProduct is quite efficient, so it compresses quite well. We'll take about 15 seconds to open that file. So here we go. So we've got internal ship under construction. Some data captured with the handheld scanner. Looks quite nice. Okay, so first step will be let's set up with our orthographic camera in the side view. We can see we don't have good registration with the coordinate system. It's rotated and twisted back a little bit. So the first step will be to get some of this data and make it align with the coordinate system. So to do that, I'm going to reduce my view a little bit. Just cut down in the top here so we can see inside, something like that. And looking down in the top view, I'll just get some of this off here as well. Looking down in the top view, we can see some framing here that's quite flat and horizontal. So I'm going to fit a shape, and to do that, I'm going to take my paintbrush here, and I'm just going to paint across. I'm going to select some points. Essentially, I'm going to pick some points on some of this framing, just by using the paintbrush. Just go across here and pick some of these up. I mean, I can use lots of different selection tools, but I'll just use this paint brush. It's pretty quick. I can see the points that I want. And Control Z if you make a little mistake. I got a roller mouse wheel, so when you go vertically, it can be harder. Okay, so I've got some points picked on this planar surface here. Let's go ahead and fit a plane through that. So I have a plane. Let's have a look at our plane. Our plane is slight rotation, you can see here, from the normal axis of the coordinate system. So we want to get that out and make things orthographic so it works with our CAD data. So to do that, I'm going to use a registration tool. I'm going to use a coordinate align registration tool. And I've got my point cloud picked, and I'm going to take this marker that says this is the top view. I'm going to drop it here on the point cloud. And then I'm going to compute the transformation, so you can see a slight rotation. And the reason I use this plane was because it has a very good quality surface normal. So if we look at our plane, where it did have a 2-degree rotation before, now it's nulled out and it's completely aligned to the coordinate system. If we look from the side view, that plane will essentially disappear because it's completely lined up on the XY plane in our coordinate system. So we don't need that plane anymore. We've got it, the data lined up. And the next step will be to look at some CAD data. So we got our DotProduct data here. I've got AutoCAD running as well. Here we have some design data for the ship. And I'm going to move that over to Bloom. Bloom is a 3D environment for both point clouds and for CAD data. So I'm going to go to the Add-ins tab. Here's the Bloom Connect plugin, and we're going to push this export button, and you'll see Bloom in the background receiving that data, and that's basically how fast it is to move the data from AutoCAD into Bloom. So here we have our design data, a little more data than I want. I'm going to pick this thing here on the top, and I'm going to hide it. I'm going to pick these frames on the side and hide them. Now I can kind of see inside. So I want to be able to register now the Bloom or the DotProduct data to the design model. So I'm going to bring up my my view frustum again, and this time I'm going to get rid of some of this top stuff here so I can see inside and get the registration a little tighter. So again, we'll look down in the top view. I'm going to pick my point cloud, and we're just going to use a transform tool here. So we'll pick up our DotProduct data and move it over. I see some features, some of these vertical pipes here. I see a lot of framing. So I'm just going to center up the DotProduct data on top of the model, like that. And if we look in the other view, see we've got a big Z transformation here. So we'll just lower this down so it's coincident with the top of these frames. All right, so there we go. We've got to move it over here a little bit. All right, so we've got the data sort of registered now with the design model. Let's set up in a perspective camera. So now we start to look around and see where the framing, it's pretty much where they would expect it to be. Um, Here's something interesting here. There's a couple places where the pipes, particularly this yellow pipe, is quite a bit different from the as-built. So that's one of the things we can do with laser scanning and 3D capture, reality capture, is compare the as-built to the design model. See, this one down here is quite a bit different too. So let's have a look at this yellow pipe. And we see it's not in the right spot. So I'm going to, again, I'm going to take my view here and get in on this one area so we can see it revealed a little more. Take the top view down, something like that. Okay, so now we got a pretty good access to this data, and we can see the difference in the design model from the as-built. Some other features here that are different. All right, so let's say we want to communicate this data back to AutoCAD. So we'll go back to our fit shape tool, and I'll use my brush again, and I'm going to pick some of these points on this pipe. Now this brushing tool is quite special in that you'll see as I paint, I'm not picking any of the points in behind. I only pick the front-facing points. So it's a lot more like picking in your CAD model. When you pick on an object in your CAD model, you pick the first object in the z-axis, or the depth, for lack of a better idea. But anyway, so I pick some points here on the shape of the cylinder, and we'll go ahead and we'll stick a cylinder on that one. And then there's another, makes a right angle turn up here. So I'm going to pick some of these points. I just type U to unselect when I'm doing my selection. I'll fit another pipe across this side. Alright, so we got our pipes. That's all good. Now we want to share this pipe with AutoCAD. So let's jump back over to AutoCAD and let's zoom into this yellow pipe. Here's our yellow pipe. We'll get the view lined up where we can see our pipe. It's not so easy to see, buried deep inside. Alright, so here's our yellow pipe, and we'll use the same bloom connector, but this time we're going to import, we're going to bring in these cylinders. So there's our cylinder brought in from AutoCAD. See the layer here, 80 bloom, Autodesk bloom connector. So we've imported this cylinder from Bloom, and it's actually constructed in AutoCAD as a solid cylinder, right? We send over the radius and the center line of the cylinder. So we're able to send that data over to AutoCAD pretty easily. Let's go back to Bloom. You might also be interested in getting some of the point cloud data in AutoCAD. And one of the more powerful things that we can do is we can really control the number of points that we send into AutoCAD, which is really important, when you have really large data sets. So and I can also cut the view. We've got all of these points, but I'm only going to send these points to AutoCAD just for this area around this pipe. So back over to AutoCAD, into the connector. This time I'm going to bring the point clouds in. So I'll say import, and you'll see Bloom running in the background there. It's sending the point clouds to AutoCAD. So it's going to write those out, and it'll give us a message when it's done. And we'll just be patient here in AutoCAD, and there's our point cloud. Okay, so we've been able to bring the geometry and the point cloud from Bloom using the DotProduct handheld scanner and the modeling and extraction features in Bloom. So that's kind of neat stuff. Let's turn on the CAD model, and let's say we want to document this particular part of the problem with the ship under construction. So I can probably be a little more generous with my shape. I'll maybe add a little bit more of the vertical surface just to give people an orientation of where they are in the model. So here I have a model, and I'm just using the space bar to fit the view and put that up here. Let's take a look at publishing. So we'll take this data, and I can send lots of points because it's a fairly low-res data. So I'm going to publish that. So you see it takes less than 5 seconds to open Chrome and draw our model. So I'm able to preview this locally on my local machine. And if I look at the results, that's a 2 megabyte point cloud, so it's pretty easy to handle on your mobile phone, 2 megabytes. I'm going to give it a name. I'm going to say, I'll call it pipe, as built, just because I don't have much imagination today. So we'll stick that in there. Pipe as built. So you see our published doc now has this name, pipe as built. And I'll say upload. And we'll take that data and we're going to push it up to the Bloom Cloud application, which is also running here in Chrome. So here's our desktop application for Bloom. And got quite a few projects up here, but if we go down to our NRCP project, here it is here, you can see the article, Pipe as Built, that we just published at this date and time. So I'll just open that one up. So here's the model we just created in literally 4 seconds in Bloom, and we can stick that up onto the website. You know, we can do some basic dimensioning in here. We can go in here, we can set up some you know, cross-sectional display culling, and generally push that up onto the cloud for approval and distribution to whoever's interested in why this pipe's in the wrong spot. So that's a bit of a summary about how we can use the DotProduct held hand scanner together with Bloom and integrate that data with AutoCAD and collaborate on the web. All right, thanks for watching.